All right, so we are at the second part of the section 5.2, and you may remember in the last class we were discussing about the sum and difference formulas for sines and cosines. Using those formulas, you can find out the cosine or sine for any sine, cosine for sine for any angle, if the angle can be represented as an addition or as a difference of two other known angles. Okay, you know, we have a plenty of angles, and not plenty, in fact, infinite number of angles. Now, but out of all those angles, some of the angles are well known to us, like 30 degree, 45 degree, 60, 90, 120, 180, 150, and also we have looked at their values, and we know some, you know, some tricks and tips so that we can just quickly find out their values. So sometime what we do is we just try to find that if we have some angle, can we represent the angle just as sum or a difference of two other angles? If we can, then these are the best choices we have. These are also useful for some other purpose, which we will understand when we'll start discussing the next section. Now here today also we are in the same place, but we'll be talking about the sum and difference formulas for tangents. Now if you look at this one, here we have two formulas just like the sine and cosine, and therefore tangent, one is the addition and one is the subtraction. So, and the subtraction and addition are simple, because if you see the addition and subtraction, their terms are exactly same except their signs. If you look at their numerators and denominators, whenever we are talking about the addition, I'm talking about the sum, you see the numerators we have positive and here in negative. Okay, and the denominator we have the reverse version, so we have negative here and positive here, except that the formula terms are same. So as long as you have some angle, and you can represent the angles as the sum or difference of two other known angles, because you know the known angles you can always have the value even without using your calculator most of the cases. So you can do that, and so you can. So we'll do some exercise and see whether we can use these formulas, and so we'll come back to the formula once we know. So let's try one tangent here. So you see here tan pi minus theta here. So again we have two angles, one is pi and one is theta. So if we just assume that the pi is alpha and theta is your beta, so you can simply plug into, so the formula for pi minus beta, and what we are going to do is we'll just assume that we'll be using this formula, which is tan alpha minus beta equals to tan alpha minus tan beta over 1 plus the tan alpha times tan beta, right? Tan alpha times tan beta. So, and the angles we have are pi and theta. Now let's try and see whether we can plug the value and we can calculate it, but make sure you know here theta is an unknown angle for you, but the pi is not unknown. You know the value of the pi, 10 pi. So you can also check your calculator, because the pi is 180 degrees, so the 10 pi means 180, and see how much you get from there. Alright, so any question here? So what is your answer? Everyone has the tan theta? I thought there must be something negative sign. Yeah, it should be negative something. Or you may be able to cancel out something. Okay. Here. So the alpha is your pi. So let's 10 pi minus 10 theta over 1 plus 10 pi times 10 theta. Now what is 10 pi? What is 10 pi? 1080. 0. So everyone has 0 for 1090, right? I'm sorry, 180. So because the sign is 0 so at 180, so 10 is nothing but sine over cos. Cosine is 1, and I'm sorry, the negative 1. But the sign is 0. So is 0 minus 10 theta again. So let's write it. So 1 plus 0 times 10 theta. So you will have 10 minus 10 theta over 1. So the answer should be minus 10 theta then. So everyone has the same answer? Negative 10 theta. Alright, so let's look at, so these are some review questions from the previous formulas. Now let's try this one and then we'll go to the next section, which will be the section 5.3. So here you are applying the sine formula because your angle is a difference, is represented as a difference of two other angles, which are 2 pi by 3 and pi by 4. And the formula you will be using is formula for sine alpha plus beta, so which is sine alpha plus beta, and the formula is going to be sine alpha times cos beta plus cos alpha times sine beta. So your alpha is 2 pi by 3 and the beta is pi by 4. Alright, so you have answer for the sine. Which one is the right answer? If you are doing everything in the calculator, so then you have to again do the math here for every answer just to see. And also just as a reminder, because I know that sometime you probably will be able to find the answer using the calculator, because what you can do is you can just, let's say, whatever the angle you were given, you can just plug into the angle into the calculator and you can get the answer. But be careful because it's not the right approach, because we understand that you don't have to show the steps in MyMATLAB, but at the same time you will see some question like this. Look at the next question. So here you have a theta, right? So anytime you have the theta, you have to apply it to the formula. You cannot get it from the calculator, right? So be careful about that. So it's not only about, just plugging into the calculator, because I know that probably, let's say, if you have sine 75 minus 30, so you can just 75 minus 30 is whatever, 45. Or even if it is some odd two angles, you can just add and subtract those and you can plug into a calculator, you can get the answer. But I would recommend that you can do that just to verify your answer. But because whenever you have something else, like something with theta, you will be in trouble if you are doing that always. So you have to always know how to do that. And also in the next section, which is absolutely dependent on these formulas. Okay, so we have to know and use these formulas for that as well. So any answer for this one? So the first angle was, what is the first angle? 2 pi by 3, 120, right? That's in fact 120. And the second angle was 45. Sine 120 minus 45 is sine 75. So you can write your question like sine 45 plus sine 30. There's the same question still, because you are just you have the same angle, but now instead of writing the angle as the difference of two other angles, you are writing the same angle as addition of two other angles. So your answer will be same. But the good thing is right now you know the 45 and 65 for sine and cos, so which is easy to apply. So if you do that, you can just follow the formula we have there. Right now, for an example, if we assume that the alpha is 45 and the beta is 30, so let's write it. Let's write the formula: sine pi by 4 times cosine pi by 6 plus sine pi by 6 times cosine pi by 4. Now remember this. Probably we should have written it backward, but this is still right. So this is another option of some tricks sometimes you can apply. So sine 45 is 1 over square root 2, cos 30 is square root 3 by 2, and sine 30 is half. Cosine 45 is 1 over square root 2. So in both cases, you will have square root 2 over 2 root 2 plus 1 over 2 root 2. And then if you add 2 square root 2, and you will have square root 3 plus 1. Now, if you look at the answer and check the answer, you see that none of the answers are matching right. It's matching right now, right? So you can do little extra math here. So one option is you can multiply. If you just, let's see, look at the denominators in the answer. Now, which one you think close to this denominator? First of all, number A, the denominator is a square root 3, which is not close at all, because our denominator is 2 root 2. The next one is 2, which is also close, and the 4 is also close. By close, I mean that which one is easy to get from here. So what you can do is you can just multiply both denominator and numerator by square root 2. If you do it, what happens? If you do this, then you are basically doing square root 2 times 2 square root 2, which becomes 4 right now. Because this is square root 2 and the other square root 2 becomes 2. Because if you are multiplying 2 square root 2, that becomes 2 square root 2 whole square, which is 2. So that becomes 4. Now your answer will be matching exactly with the option D. In case of multiple choice, you always will have this kind of risk. You might have some answer in one form and answer is given in another form. So the right answer will be D here. Another option is if you just completely break everything down to decimal fraction. So it doesn't matter what form you have, you will always have that matching. But in that case, you have to get the decimal fraction of your answer, and you have to have the decimal fraction of all of the options. Then you will, as long as decimal, it will be something like something point something. It will be close enough. But in most cases, since you have like square root or square root 3 or square root 2, you will not have exactly accurate one, but probably the close one. Any question here? So, this is another probably lesson for us, that sometimes if the angles are not familiar to you, or probably you don't know the, for some reason you don't know what will be the angles in fraction, you will always know the angle in decimal fraction since you have the calculator. You can break it down and write it in terms of another two angles which are known to you, if it is possible. That's one other option. Any question? Okay, if not, so let's move on to the next section, which is section 5.3.